Hello dear students, I am Pierre, Faculty of Mathematics. Today I am with you with different topics. So I shall discuss algebraic functions and their graphs. So the functions to be identity function, polynomial function, rational function, irrational function, modulus function, greatest integer function, and least integer function. So I shall discuss each and every functions with their proper graphs. So let's start. Let us discuss identity function. A function f defined by fx equal to x for all real values of r is called identity function. Let us see its graph. Here we have y is equal to x. So taking x equal to minus 2 minus 1 0 1 2, we get y also minus 2 minus 1 0 1 2. Plotting these points on xy plane, we get a straight line passing through the origin. Now it is seen that the straight line make angle 45 degree in positive direction with x-axis. So we can say now identity function represent a straight line passing through the origin making angle 45 degree with x-axis. We get domain of this function is the set of real number and range is also the set of real number. Next we discuss polynomial function. A function of the type fx equal to x square, x cube and so on is called a polynomial function. Domain of polynomial function is the set of real number r. We take an example fx equal to x square. For this, considering x equal to minus 3, minus 2, minus 1, 0, 1, 2, 3, we get y equal to 9, 4, 1, 0, 1, 4, 9. Now plotting these points xy in our xy coordinate system, we get. By plotting these xy values on coordinate system, we get graph of this function is an upward parabola. As the values of x is the set of real number, the values of y are only positive real number including 0. Therefore, the graph lie above the x-axis through the origin. Also, the values of y are positive for all positive and negative values of x, so that this type of function is also called even function, and this graph is always symmetric about the y-axis as seen in this diagram. From the graph we get domain of this function is the set of real number r and range is positive real number including 0 or 0 to infinity. Next we discuss about the rational function. First of all, definition is a function of the type px by qx for real x and not 0 is called a rational function. Let us see its graph. Let us take an example fx equal to 1 by x, x is not 0. As y is equal to 1 by x, for x equal to minus 4, minus 2, minus 1, 1, 2, 4, y equal to minus 0.25, minus 0.5, minus 1, 1, 0.5.25. By plotting this point on xy coordinate system, we get two curves, one curve in the first quadrant, other curve in the third quadrant. As x is positive, y also positive, so we get the curve in the first quadrant, and as x is negative, y also negative, so we get the other curve in the third quadrant. So since x tends to infinity, y also tends to infinity, and since x tends to minus infinity, y also tends to minus infinity. Both the curve will not touch x and y coordinate axis, because if x is equal to 0, then the curve may touch the y-axis or x-axis, but x cannot be 0, therefore the curves cannot be touched with the axis, but Both curves are very close to the x-axis and the y-axis. This is the graphical concept of rational function. Next, we discuss irrational function. Definition is an algebraic function containing terms having non-integral rational powers of x are called irrational function. Taking an example, fx equal to root over x. Domain of this function is positive real number including 0 or close 0 to infinity. Taking x is equal to 0, 1, 4, 9, 16, we get y is equal to 0, 1, 2, 3, 4. Now plotting these xy points in our coordinate system, we get a curve as shown in this diagram. This curve is a portion of the parabola y square equal to x, which lie above the x-axis. Clearly, range of this function is positive real including 0 or 0 to infinity. From this graph, we also seen that the line y is equal to x intersect the curve at the point 0, 0 and at the point 1, 1. This indicate that the curve will have the equal x and y coordinate at the point 0, 0 and 1, 1. This is the graphical representation of irrational function y is equal to x to the power half or y is equal to root over x. Next function is modulus function. This function is represented by y equal to modulus x. It has two values, y is equal to x for x greater than or equal to 0 and y equal to minus x for x less than 0. Clearly, domain of this function is the set of real number R. Now taking x is equal to minus 2, minus 1, 0, 1, 2, we get y equal to 2, 1, 0, 1, 2. Here, the values of y will be positive for negative, positive and 0 values of x because y equal to modulus x is positive value. By plotting these points on xy coordinate system, we get two straight lines. One straight line in the left hand side represent the equation y equal to minus x and other straight line in the right hand side represent the equation y is equal to x. So first straight line y is equal to x make an angle 45 degree with x-axis, and the second straight line for y is equal to minus x make angle 135 degree with positive direction of x-axis. As the values of y are positive for negative positive values of x, we get both the straight lines above the x-axis to infinity. So we can say now both the straight lines giving the values from 0 to infinity. That is why range of this modulus function is always 0 to infinity. Again, this modulus function is symmetric about the y-axis in its domain set of real number. This is the graphical representation of a modulus function y equal to modulus x. Hello dear students, we have other two functions, greatest integer function and least integer function. I shall bring them both in the next video very soon. Now I hope you can understand the functions and their graphs. If you are satisfied with this video, please subscribe my YouTube channel and comment in the comment box or rate our EduCap coaching in the Google site with your comments. Thank you for watching.